Okay, so we're gonna test the claims about the mean sigma not known. What do I mean by sigma not known? That means the population standard deviation is not given in the exercise. So what's given instead is the sample standard deviation, which is S. Remember, guys, when sigma is known, we must use a Z distribution. When sigma is not known, we must use a T distribution. And you notice, guys, here, look, for the test statistic, it's T, it's not Z. So I put T here instead of Z. And let me show you how this problem works. The amount of water consumed per week by Montana residents is normally distributed with an unknown mean. A simple random sample of 26 residences. So N is 26. So let's start writing down. Has a mean value of 120.3. That's X bar. Gallons. And a standard deviation of 10. He didn't say this is a population standard deviation. He's referring to the sample. Look, the sentence started. A random sample of 26 has a mean and a standard deviation. That means S is 10. The city of Bozeman claims that the average water consumed in the state of Montana is not 125 gallons. Who can help me to state the null and the alternative hypotheses? What do you guys think the null and the alternative are going to be? Any response?
The null is 125 gallons, while the HA is not 125 gallons, and that is the claim.
That is absolutely correct. So the claim is in the alternative hypothesis. They say the state of Montana claimed that the average water consumed is not 125. Is not means, guys, not equal to. Don't expect me to give you the sign of the problem. It's going to be in words, guys, so you need to know how to interpret the sign. That's very, very important. Okay, very good. That's
Mr. Bazzi, you put 120. Should it be
125? I'm sorry. You're absolutely correct. $125. Thank you for noticing. Okay. Since look how simple it is to make a decision. Which test do you use on the calculator? So we're going to be using the p-value. There is another method called the critical value, which I'm going to show you today, but you will be given the choice to use whatever value, whatever method you like. And I do recommend the p-value because you can use it off the calculator. Since S is given instead of sigma, guys, you must use a T and the distribution. And then if it is a T distribution, then we must use the T-test. Let me show you how to use the T-test. Turn the calculator on, go to Stat, Tests, and look. This is what confuses students always. Do I use the Z-test or T-test? The students see the Z first, and then they end up using it, and then they end up with wrong conclusion or wrong data. And let me show you why it is wrong to use Z. Watch. You see what it asks for? It asks for sigma. We don't have sigma, we have S. But if I go to Stat, Tests, T-test, look, it's asking for S. So that is the correct one. Okay. mu0, you begin. You have to input the value in the null hypothesis, which is 125. Remember, we assume the null hypothesis is true until proven otherwise. Remember, the defendant is not guilty until proven otherwise. So this is the same way it works. X bar, 120.3. S, 10. N, 26. And what do I select before I hit calculate? The alternative sign, guys. The alternative sign is not equal to, so you select that. the calculator needs to know whether you have a left tail test, right tail test, or two tail test. The first one is a two-tailed, the second one is less than, it's a left tail test, and the third one is greater than. Well, I have a different from, so I'll choose the first one. And I hit calculate. Here you go. So T usually is 3 decimal places, guys. So it's negative 2.397. Negative 2.397. P-value is 0.0244, 4 decimal places. And that's all I need from the calculator. Okay, I don't need the critical value here, so I just do the p-value. What's the decision at the 0.01 significance level? Circle 1. Here's how we use the p-value, guys. You need to memorize this. If p-value less than or equal to alpha, we reject HO. If p-value is more than alpha, the significance level, we fail to reject HO. You don't need to write this down, but you need to choose one of them. Okay, my p-value, guys, is 0.0244. And my alpha, he says 0.01. Can you compare them, guys? Is 0.0244 bigger than 0.01 or less than 0.01?
It's larger than. Or greater.
Larger than. Well, if it is larger than, guys, you're here. Then you have to fail to reject HO. And if I ask you justify why, because p-value is more than alpha. All right. So this is number 4. Now, how would you write the conclusion based on your claim? Here's how you begin, guys. You start. Since you fail to reject HO, you start with there is not. So always fail, you begin with not. Enough evidence at the 0.01 level of significance. When you do exercises online, you have to select, the step. So he's gonna give you 4 or 5 choices. You have to select one of them. So anytime you have a fail to reject HO, you start with there is not. Enough evidence at the 0.01 level of significance 2. If you are working in my math lab, it's gonna give you 2 words to select from, to support or reject here. Because your claim, guys, is in HA, you always select the word support. You don't use the word reject at all. So there is not enough evidence at the 0.01 level of significance to support the claim that, and just copy it and paste it, guys. The average water consumed in Montana is different from 125 gallons. We're saying we cannot support the claim that the water consumption is different from 125 gallons. All right, any questions? Okay. I think we did number 3 last time, guys, so I'm gonna skip that, but I will send it to you with the solution of, do you guys recall if we did that, a credit card company wondered whether giving frequent, you know what, I'm gonna do it one more time. A credit card company wondered whether giving frequent flyer miles for every purchase would increase card usage, which has a current mean of $2,500 per year. So they want to check if they can increase the card usage, which is currently at $2,500 2,500. Remember, increase means go beyond, go more. They gave free miles to a simple random sample of 24. So N is 24, guys. And found that the sample mean to be 2542. So that's X bar. With the sample standard deviation. There is no way, guys, that you can go wrong here. He's telling you sample standard deviation. Don't put sigma here. It's a big deal. You have to put S, because the label that you put will decide, the nature of the test that you have to use. So he says S is 109. State the null and the alternative hypotheses. Can someone remind me what should be the null and what should be the alternative? They want to see if they can increase card usage beyond 2,500. So what would be the null and the alternative, guys? Any response? Increase means beyond 2,500. And then that other one, the null hypothesis will be less than 2,500 or equal to. So that's the claim. Okay, that's a t-test. Here you go. Let's do it together. Stat, tests, t-test. Okay, 2,500 here. Oops, sorry. Need to fix this. X bar 2542, S 109, N 24. And then we need a greater than. Don't forget, guys, you must change this. It has to blink on the one that you select. And look, it is blinking now. And now let's do a draw. I can show you the p-value. The p-value is an area to the right now because it's a right tail test. Watch, guys. It goes a little bit slow because it does give you a curve, detailed curve. Here's the p-value. It's being shaded now. Okay, so T is 1.888. I do remember we did this last time. And the p-value is 0.0359. Okay, make a decision, guys, at alpha equals 0.01. What do you think? Is the p-value bigger than alpha or less than alpha? This is 3.5%. This is 1%. So you guys agree with me that this is bigger than alpha. So the decision will be fail to reject the null hypothesis. As I told you when I first introduced this chapter is about making one of two decisions, either reject the null hypothesis or fail to reject the null hypothesis. And your conclusion. Okay, I'm gonna try to be consistent, guys, of what I said earlier. When I say fail to reject, you say there is not enough evidence at the 1% level of significance or 0.01 level of significance. 2, can someone tell me what's the word here, support or reject?
Support.
Support, yes, because the claim is in HA, you use the word support. We're not saying we're supporting, we're saying we're not supporting. There's not enough evidence to support the claim that given frequent flyer miles for every purchase would increase card usage. That giving frequent miles for every purchase would increase card usage. So that means the card company should revisit this proposal, this initiative, and probably discontinue that if it's not helping them. All right, next one. I'm gonna go to the next question.
Mr. Bazzi,
Mm-hmm.
if the claim is an HO and then you failed to
To reject HO, yes. What do you say? You say
It
there
would
is
be
not
there-
enough. Yes, go ahead.
would it still be there is not enough evidence, or would it be then
Yeah, there is not enough evidence, but not to support the claim, not to reject the claim. So
there's
you
not
say
enough
that you
evidence?
cannot reject the claim.
So at no point, if HO has failed, do we say there is enough evidence?
Never.
Okay, because we're never trying to reject it.
No, yeah. So if you fail to reject HO, the word fail, you must start, with there is not enough evidence always.
Okay.
But you say there is not enough evidence to reject HO, but it doesn't mean that you accept it. I mean, you're saying I give up, that's it, I cannot reject it. But it doesn't mean that you support, this. You just cannot reject it.
Yeah.
When they say we don't have enough evidence, just to convict a person, it doesn't mean, that the person is innocent. It just means that they don't have enough evidence at the moment to convict, just a person. So
Okay.
This is the language of a hypothesis testing.
Okay, thank you.
No problem. Good question. A fast food outlet claims that the mean waiting time in line is less than 3.5 minutes. Okay, that's clear, guys. You should be able to write the null in the alternative. They're saying less than 3.5 minutes. Remember, guys, the less than, the greater than, the not equal to should be in HA. And then the greater than or equal to, less than or equal to, and equal to should be in HO. Since he says less than, if I were you guys, I would write those always with any problem I do. I put those three signs in HA and put those three signs in HO, and then I read what he says. He says less than 3.5 minutes, so that means this one, and then your null hypothesis will be the complement of it right here. So that's your set right here. So mean, it's all about the mean, no proportion yet. That's the claim, guys. You tell me, how do I know? Look, it says it claims that. And then the other one will be greater than or equal to 3.5. A random sample of 15 customers, so N is 15, had a mean of 3.4 minutes, so X bar is 3.4. With a standard deviation of 0.6, this is S, guys. He didn't say with a population standard deviation, so it is S. If alpha equals 0.05, the level of significance, test the fast food outlets claim. Don't worry about this. Assume that the population is normally distributed. The reason why he told us that the population is normally distributed because he gave me a sample size less than 30. Then the original population must be bell-shaped. Okay, t-test, guys. There you go. I hope that the t-test is making sense to you now. And let's do it. Stat. Okay. 3.5. So you begin, guys, this value in the null hypothesis you put right here. Then you put X bar, which is 3.4. Then you put S, which is 0.6. Then you put N. I don't remember what N was, 15. Then, which sign do I choose? Can a student tell me, is it first, second, or third?
Second.
Second. And don't forget, guys, you must go to it and look. I'm going to show you what I'm doing here. Enter. You must do that. And let's do a draw so you can see the p-value in action. If the p-value is shaded, it's going to show on the left, guys. Watch. Oh, it's a huge p-value. That means you're going to fail to reject HO. Oh, wow. So T is negative 0.646. If you guys have a left tail test, expect T to be negative. If you have a right tail test, expect it to be positive. If you have a two tail test, it can be either one. P-value. Okay, according to my calculator, guys, it's 0.2645. And you guys agree with me that this is bigger than alpha, which is 0.05. 26%, guys, is bigger than 5%. So what's the decision? Reject HO or fail to reject HO?
Fail
Fail
to
to reject.
And if you want to know why, because p-value is more than alpha. Guys, I'm being consistent. I'm not giving you anything, any new methods every time. That's what I told you, that chapter 7 is critical, because once you learn how to do the steps in chapter 7, you will see in 8 will be the same, in 9 will be the same. It's going to be the same. So throughout. Interpret your decision. Okay, well, it's been happening. It's always failed to reject. To be honest with you, I didn't intend to make it this way, but it happens. So there is not enough evidence. In my math lab, when you select step 5, it's going to give you a drop-down menu. There is not. You have to choose there is not, because you failed to reject HO. So there is not enough evidence at the 0.05 level of significance. 2. Then a drop-down menu in my math lab will show you support or reject. Well, since the claim is in HA, you have to use the word support. So we cannot support the claim. There is not enough evidence at the 0.05 level of significance to support the claim that mean waiting time. So probably they're lying to us, guys. And line is less than 3.5 minutes. All right, any questions? Okay, for the next question, guys, I'm gonna pause for 1 minute until you put your data into your calculator, because that's gonna be with data, and we have to put it in L1. Anytime, guys, you see a raw data set, make sure to put it in your list, because in order to process this, we need to have the data ready. So, okay, guys, this is a very interesting problem. Carolina Tobacco Company advertised that its best-selling non-filtered cigarettes contains at most 40 milligrams of nicotine. What is at most, guys? Can you remind me what sign do you use for at most?
less than or equal to.
Yep, you need to know this, guys. So it's gonna be mean, less than or equal to. Look, guys, just consistency, these two. All right. But Consumer Advocate magazine ran tests for 10 randomly selected cigarettes and found the following amounts in milligram. It is a serious matter to charge that the company advertising is wrong. So the magazine editor chooses a significance level of 0.01. So alpha is 0.01. Can the editor prove that the mean nicotine level is greater than 40 milligram? Where is the claim, guys, now? It's about the editor making a claim, not the tobacco company. We're trying to answer the editor's question. Can the editor prove that the mean nicotine level is greater than 40 milligrams? Where do you think the claim, guys?
In the HA.
In the HA. Although some students might tell me, Mr. Bazzi, they started advertise that it's best-selling non-filtered. They were not making claim here. They advertised that this is the case, but somebody else came from a magazine, got suspicious about this advertisement and want to make the claim. So it is the magazine's editor claim that we need to verify. We're not saying we're gonna support, we're just gonna verify. So that's the claim right here. Guys, if you have raw data and he doesn't give you population standard deviation, then it's a t-test, period. So that's a t-test. And let me show you how to run this test. Stat, tests, t-test. See how popular the t-test is. Okay, here is the difference between this exercise and the exercises we did before. We have to jump to data now because I have the actual data set. So you go to data, and then mu0, it's the value in the null hypothesis. What is the value that we're going to assume it is true until proven otherwise? Then your list is in L1. Don't touch the frequency, guys. And we need the third one here, as you can see. And I can do a draw. So if you see a p-value, guys, it's going to show on the right here because this is a right tail test. Watch. You can hit calculate as well. You don't have to. Okay, it's a small p-value, as you notice. It didn't shade much. So T is 2.746. And the p-value, let me write it down, 0.0113.
I'm not sure how, but I got a different value than you.
You did?
Mm-hmm. I got the same t value, but not the same p value.
Let me double check. Yeah, if you don't change the sign before you hit calculate, it's not going to give you the correct p-value. That's why I said it's very, very important you do this, guys. Okay, so the p-value, let me write it down here. And the alpha is 0.01. Okay, comparing, guys, for me, what do you think? Which one is bigger?
The p is greater.
Oops, failed to reject. We haven't rejected HO today yet. So there is not. Oops, right here. Failed to reject. There is not enough evidence at the 0.01 level of significance to support the claim by the magazine editor. We cannot support the claim. You see, there is not, and the word support, guys, when the claim is in HA. If alpha was 5%, I might give you this problem, same problem on the test, guys, and I'll change alpha to 5%. What will happen if alpha is 5%?
Then you could reject HO.
Then you reject HO, and look what you say, guys. There is enough evidence at the 0.05 level of significance to support the claim. So instead of not, you just say there is enough evidence to support the claim. So then you guys, you should understand and value how important it is to know the p-value, because based on the value of the p-value and when you compare it with alpha, your decision, it's going to be either to support a claim or not supporting a claim. When you support a claim, you're telling people go ahead with it. When you don't support it, you're telling people there's something wrong with it. So you need to go back and revisit. So this is a big deal here. All right. So this is section 7.3. Now I'm going to go to section 7.4, guys, and then we're going to review both sections with more exercises. So as you can see from the title here, it's testing the claim about the proportion, not about the mean anymore. It's the proportion. So it's a P. Okay, let me show you how, I'm gonna go to an example right away, guys. The engineering school at a major university claims that 20% of its graduates are women. In a graduating class of 210 students, 46 were women. Does this suggest that the school is believable? Okay, guys, can you tell me what would be the null and the alternative hypothesis? The engineering school is making a claim that 20% of its graduates are women. So once you start talking about the percent, guys, it's a P here. What would be the null and the alternative?
P equals 20%.
Yes. And that's what their claim is. Very good. Okay, what do we have here? In a graduating class of 210 students, so N is 210, 46, that's X. Just like the confidence interval for the proportion, guys, you need two values. You need to know how many total were involved in the survey and how many answered in your favor. So that's X, we call it the number of successes. And this is alpha, guys, which is 0.05. Okay. If he asks you guys to verify that we can run a hypothesis test here, if he asks, here I didn't ask, but if you are asked while doing your homework to verify that we can run a hypothesis test on this proportion, you have to do the following. You have to check that NP is greater than 5 and NQ is greater than 5. And let me tell you what I mean by that. N is the sample size, 210. P is the value in the null hypothesis. What would that be as a decimal, guys? 20% will be 0.2. If you multiply 210 by 0.2, guys, you would agree with me that you get a number bigger than 5, so that's a yes. Does anyone know what Q is?
Wouldn't that be 80%?
80%, exactly. And this is bigger than 5 as well, guys. So since the two conditions are verified, we're gonna go ahead and perform the test. However, if he doesn't ask you guys, if there is no question, just go ahead and show the steps. So the first step is P is 20%. The second step is P is not equal to 20%. Since this is a proportion, guys, there is only one test on the calculator. It's called one prop Z test. This is the test that you have to use. It's called one prop Z test. And let's show it to you. Stat. So number 1 is reserved for the mean when sigma is known. Number 2 is reserved for to test the mean when sigma is not known. And let me tell you which one is. So in this chapter 7, there are 3 tests. Number 1, number 2, and number 5. There you go. Okay, guys, can you help me out? Fill in the blanks. P0 is what you have in the null hypothesis. P0 stands what is the assumed value in the null hypothesis to be true until proven otherwise. It's 0.2. What is X here? 46. X is always the smaller number, guys. What is N? 210. And what we're testing, not equal to. You see, I select not equal to, and then I'm gonna hit the draw. If there is a p-value, if the p-value shows, it's gonna show on both sides of the curve because this is a two-tailed test, guys. Watch. Oh, it's a huge p-value. All right. So Z is 0.69, as you can see, guys, and the p-value is 0.4902. So we're using the p-value method. And you guys agree with me that it's definitely bigger than alpha. Anytime, guys, you see too much shading, you're going to fail to reject HO because the p-value is bigger than alpha. All right, so fail to reject HO, and if you want me to put the reason, because p-value is more than alpha. Conclusion: interpret your decision in the context of the claim. This is for the reader. So you begin. There is not enough evidence at the 0.05 level of significance to, who can tell me what the word is going to be here? Remember, the claim is in HO.
Reject.
To reject the claim, exactly. There is not enough evidence at the 0.05 level of significance to reject the claim of the engineering school. Okay, let me ask you a question, guys. Does this suggest that the school is believable? Yes or no?
Yes.
Yes, we could not reject their claim. That means they're probably believable. Yes, the school is believable. If I cannot reject your claim, so probably you're right. So that's what we're trying to say here, guys. All right, next one. This is a real life situation problem, guys. So I got it online. So I think it's accurate information here. Next exercise about the proportion. Any Boston Celtics fan or archival knows that Shaquille O'Neal, one of the NBA's most dominant centers of the last 20 years, always had difficulty shooting free throws. Over the course of his career, his overall made free throws percentage is 53.3%. So he was accurate 53.3%, but 46.7% no. During this off season, Shaq is working with an assistant coach on his free throw technique. During the first 5 games of the next season, Shaq made 26 of his 39 free throw attempts. So he was able to hit it 26 times out of the 39 times. Do the results provide convincing evidence that Shaq has significantly improved his free throw shooting? Carry out a significance test at the alpha equals 0.05 level. What he's telling us, guys, that his free throw percentage is 53.3%. He's practicing to improve this. We want to know if he was able to improve the 53.3%. What would be the null and the alternative hypothesis in this case? Any suggestion, guys? So again, that's what he was, and he's practicing to see if he can do better than 53.3%. So out of 39 free throw attempts, he made 26. What would be HO and HA? It's a percent, guys, that we're trying to verify. Does a student know what would be the null and the alternative here? Do the results provide convincing evidence that Shaq has improved his free throw shooting? What does improved mean?
Greater than 53.3.
Very correct. 53.3%. That's the claim. If you improve, guys, your percentage has to go up. That's what it says here. Okay, it's X is 26 and N is 39 and alpha is 0.05. And it is a one prop Z test, guys. Okay, let's do this.
Can you explain one more time how we know that's a one prop Z?
Oh, because it's a proportion. We're trying to check if his percentage has improved. Anytime the question is about the percentage, it's a proportion.
Oh, okay.
Does that make sense?
Yes.
And anytime there is a mean and a sample mean and a standard deviation, guys, in a problem, you know it's about the mean. Anytime he gives you a standard deviation in a problem, you know it's about the mean. It can't be a proportion. A proportion, he'll give you only two values. What's the sample size and how many out of the sample size were success. That's it. You see here, he did 39 throws. He made it in 26 of them. So it must be a proportion. So after today's lesson, guys, you should be able to go and work on most of the problems, all of the problems and the homework. And as I told you, I will remove the problems that pertain to section 7.5. Okay, we need to enter the value in the null hypothesis, and it's 0.533. X is 39. N is 20, sorry, X is not 39, it's 26. And N is the bigger number, 39. If you switch them, guys, the calculator will halt, will not run. And what is the alternative hypothesis here? Greater than, guys, I have to choose this one. All right. And I'm gonna hit calculate this time. I'm not gonna do a draw. Faster. Watch, look how fast it is. Okay, Z is 1.67. And p-value is 0.0471. All right. Okay, guys, we need to decide to reject HO or fail to reject HO. Where my p-value, guys, is less than alpha here, which is 0.05. Yay, this is the first time we reject HO, so we're gonna reject what? HO. And if you want the reason why, p-value is less than alpha. Okay, now watch, see how we're gonna write this down, guys. Since you rejected HO, you start with there is, not there is not, there is enough evidence at the 0.05 level of significance to. Now, if you're doing your work online, it's gonna ask you choose support or reject. Since the claim is in HA, guys, you use support. So now you're supporting the claim. In other words, guys, if your claim is in HA and you reject the first one, HO, you support the claim. So there is enough evidence at the 0.05 level of significance to support the claim that, and look, guys, I'm not gonna reinvent anything. I'm just gonna copy this. Shaq has improved his free throwing technique. the first time we do an exercise where we support the claim. So there is enough evidence at the 0.05 level of significance to support the claim that Shag has significantly improved his free throwing technique. Okay, let's go to the next one. All right. A drug manufacturer claims that fewer than 10% of patients who take its new drug for treating Alzheimer's disease will experience nausea. Okay, guys, can you tell me what the HO and HA are? What does fewer mean?
Less than.
Less than. That means in HA. It has to be in HA. So the complement of it will be that one. So, and since at a percentage, guys, it is a percent. So you have to use P, proportion. That's the claim. That's why, guys, I spent quite a bit of time with you stating the null and the alternative hypothesis, because that's very, very important to state it properly. In a random sample of 250 patients, 23 experienced nausea. So the big number, guys, is always N, and the small number is always X. Test the claim at 5%. Okay, let's do it. We don't need to verify whether we use the claim. He didn't ask me to verify anything. When you do your homework online, it will ask you, find N times P, find N times Q, and check the requirements. Both of them must be bigger than 5. If one of them is less than 5, then you will not be able to perform the test. So stat, tests, number 5, guys. All right. Okay, what do I need to put here? 10%, watch. X is 23. Then 250. And we need less than. Don't forget, if you don't change it, you're going to get a wrong p-value. You must change this. Watch, I'm going to press enter now, guys. And hit calculate. Or draw if you like. Let's do a draw. Oh, it's a large p-value. Okay, so I got Z is negative 0.42 and p-value is 0.3366. I forgot 0.42. You see, it's negative because that's a left tail test. P-value, unfortunately, turns out to be big. Okay, that's all I need from the calculator. So your calculator gives you those 2 important steps that involve calculation, which is the hardest part. What's the decision, guys? Do you guys agree with me that this is bigger than alpha?
Yeah, we failed to reject.
Failed to reject HO. I hope, guys, that this is making sense to you now, because p-value is more than alpha. And then you start. Watch. I'm going to be consistent. I'm not going to change what I said earlier. Since I start with fail, I start with there is not enough evidence at the 0.05 level of significance. 2. Now the drop-down menu is asking me, do I use the word support or reject? Since my claim is in HA, I use the word support, guys. I cannot support the claim. See, there is not enough evidence to support the claim. The claim. And if you want to know what the claim is, here you go. That fewer, you might have to select it when you do your homework, that fewer than 10% of patients taken a new drug will experience for treating, I'm just gonna write it all, Alzheimer's disease will experience nausea. So that their claim probably not correct. We could not support it. That's the claim, guys. So there is not enough evidence at the 0.05 level of significance to support the claim that fewer than 10% of patients taking the new drug for treating Alzheimer's disease will experience nausea. All right, so this is additional exercises. Let's do some more practice exercises, guys. An airline claims the no-show rate for passengers is less than 5%. Okay, you know, guys, this is a proportion test. I'm talking about percentages. So right away, I know what HO and HA, less than 5%. This is the less than, you know, that has to be in HA. So your null hypothesis has to be greater than or equal to 5% claim. So what you need in this chapter, you need to know what at most, at least, less than, greater than, equal, not equal mean, how to interpret those as simples, which we did review. And we need to know how to change percent to a decimal. All right. In a sample of 420, that's N, randomly selected reservations, 19 were no-shows, so that's X. At alpha equals 1%, test the claim. So we stated the null and the alternative. It's a proportion Z test, guys. Let's do it. For some students who have this calculator, let me do it on that one. No, it's the same thing. Stat, tests, one prop Z test, 0.05. X is 19. N is 420. And we need less than. Don't forget, guys, again, I cannot stress enough how important to select the last step before you hit calculate. Less than, and then calculate. Okay. Z is negative 0.45, and the p-value is 0.3272. So we're gonna fail to reject HO. 45, sorry. 2 decimal places. P-value is always 4 decimal places. So it's going to be, the p-value is a probability. It has to be between 0 and 1. 0.3272. Which is, guys, you agree with me, this is bigger than alpha. So we fail to reject. And I'm saying justify your answer. To justify your answer because p-value is more than alpha. Okay, let's put the conclusion together. There is not. You ask me why I put not, because I had failed. Enough evidence at the 5% level of significance. The level of significance, guys, is the probability of rejecting the null hypothesis when it is true. It's called type 1 error, the probability of making type 1 error. There is not enough evidence at the 5% level of significance to support the airline's claim. that no-show rate is less than 5%. That's it. That is, so this is a proportion z-test, guys. Let's see what the next one is. I'm gonna pause for a second until you guys input these values in L1 or L2. You can put them in any list you want. So let's take a second to input the values. Once I give you values, guys, this is a mean. It can't be a proportion. Okay, I put my data, guys, in L1. Let's see what the question is about. A local group claims that the police issue more than 60 speeding tickets a day in their area. Okay, can you tell, guys? From there, you should be able to tell what HO and HA are. If it is a number, it can't be a proportion. Proportion is a percent. So what would be HA, guys? Greater than 60?
That's the claim. And then HO is less than or equal to 60.
Exactly. Don't forget the column here, guys. Okay. To prove their point, they randomly select 2 weeks. Their research yields the number of tickets issued for each day. The data are listed below. Test the group's claim using p-values. Assume that the population is normally distributed. They have to make an assumption that the population is normally distributed because the sample size is small, guys. It's how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, we stated the null and the alternative. And it's a t-test. Usually, guys, when you have raw data and no mention of population standard deviation as t-test, you can jump to a t-test right away. So let's do it. Stat. Oops, I have to recharge the battery. T-test. Okay. 60. My data is in L1. I don't know where you put your data, but I put it in L1. Frequency, don't change it. And don't forget, we need to make this greater than. If you ask me, guys, I tell you, this is the common mistake that students make. They forget to change the last step before hitting calculate, and they end up with the wrong p-value. So greater than. And then you want to do a draw? Let's do a draw. It's nice. Ooh, huge p-value. Too much shading means you're going to fail to reject HO. Remember what I said last week. P-value low, HO must go. Here, p-value is not low, so HO will stay. Fail to reject HO. So we have T is 0.0597. If I want to do 2 or 3 decimal places, it will be 0.06. P-value, as you notice, guys, it was big right here. 4766. And I'm gonna choose this. And if I want to justify my answer, because my p-value is more than alpha. Look, alpha is 0.01, guys. Conclusion, watch. There is not enough evidence at the 0.01 level of significance to what, guys?
Support the claim.
Support the claim. We're not saying we're supporting the claim. We're saying we're not supporting the claim. There's not enough evidence. The claim that the police by the local group. They claim that the police issues more than 60 tickets a day. Well, we couldn't support that. So then they lose the case, guys. When you cannot support, just your claim, you lose the case, because in order, just to verify a claim, you must be able to collect enough evidence to support it. Okay, so that's one.
Mr. Bazzi,
Mm-hmm.
when I was doing the homework yesterday, there was like one that gave us maybe 30 values. So it was a list like this. And I was trying to figure out, instead of inputting each one into my calculator, how to use stack.
Oh, definitely. You can use StatCrunch, which I'm going to take you to it today. You're not supposed to do it by hand. With this, guys, not a big deal. But you have 40 or 50 values. No, I'll show you how to do that in StatCrunch.
Okay, thanks.
Yeah, a good question. Question 3. Yes.
Are we going to use StatCrunch in the test?
It will be available. If students like to use it, it's available. I'm making it available.
Okay.
Yeah. It's up. And you guys, let me pause here for a second. Okay, question 3. A local brewery distributes beer in bottles labeled 32 ounces. A government agency thinks that the brewery is cheating its customers. The agency selects 26 of these bottles, so that's N, measure their contents and obtain a sample mean of 31.45, that's X bar, with a standard deviation is 0.65 ounces, that's S. Again, guys, if you ask me, how do I know this is not sigma? If he doesn't say population standard deviation, guys, it's not sigma, it's S. Use a 0.05 level of significance to test the agency claim that the brewery is cheating its customers. Who can tell me what would be the null in the alternative hypothesis? They say the beer has to have a 32 ounces, but the government agency think that the brewery is cheating its customers. What would be the null and the alternative?
It equals and does not equal 32.
Close, but not very accurate.
I thought it would be equal as well.
If you cheat someone, like, someone want to buy, let's say they want to buy fruit, and you tell them, well, this is 7 pounds, but you cheated them. When you cheat them, what does it mean? What does it mean that you did?
You gave them less.
Thank you. You give him less. But when you say not equal to, it means it could be more, it could be less. Well, more is good. That's not cheating. If somebody wants to buy 7 pounds, fruit from you, and you give him 7.5, that's not cheating. You're just being generous here. But you give him less than 7, that's cheating. So cheating, guys, means less than. I mean, I can see the argument for equal or not equal to, but remember, it's cheating. And cheating has to go below what they're supposed to give. So it's going to be mean is less than 32 ounces. Claim.
Wait, how do we know it's the mean symbol and not the P?
What is it?
See how you wrote mean and then next to the HO and then HA? How do we know it's not P is less than or greater than?
Oh, P is a proportion, only if the problem is about percent.
Oh, okay.
If you, look, here, you see the next one, what does it say?
8%?
Yeah, that's it. That's a percentage problem. So it's a proportion. Here it says, look, here is another thing also. They obtain a sample mean, so it's about the mean. A sample standard deviation, so it's all about the mean, not about a weight. When he gives you a number other than the percent, it's the mean, it's not the proportion. So it's a t-test, guys. Let's do this. T-test, why? Because S is giving. He gives us S. S is giving. Remember, S means sample standard deviation. All right, stat, tests, T-test. Mu0. Under mu0, you have to put the value in the null hypothesis, 32. X bar, 31.45. S, 0.65. N, how many? 26. Now we need to check if mu is less than 32. There you go. And I'm gonna hit calculate, guys, for you. And watch. T is negative 4.315. Good. And good, I'm glad that it happened. We get this p-value because we need to learn how to interpret this. So I'm gonna copy it, guys. It's 1.1008 e minus 4. Remember, guys, the p-value is a number between 0 and 1, so it can't. Here's what some students unfortunately do here. They put the p-value is 1.1008 and ignore the e. Well, the p-value is a probability. It cannot exceed 100%. It cannot exceed 1. It's always between 0 and 1. So you must be able to interpret what the e negative 8 negative 4 means. The e negative 4, guys, means that you have to move the decimal place 4 digits to the left. So look what this is going to be. If I move it 4 digits to the left, I need to add 3 zeros here. So it's going to be, this is my p-value. So it's very small. Look, once you see an e, you always write it's less than alpha. It's going to be very small. It's less than alpha. So do we reject HO or fail to reject HO? Definitely it's a rejection decision. So reject HO because p-value is less than alpha. Your conclusion. And we do it together. There is enough evidence at the 0.0, what was alpha here? 0.05 level of significance to support the claim that the mean is less than 32, means the brewery is what? Cheating its customers. This is very serious conclusion, guys. You're taking, the government agency has determined that the brewery is cheating, so there are consequences of this. And this is all done through hypothesis testing, guys. This is how they do it. They hire people who know statistics and they do the math in the background, you know, and then they give the results. All what the agency needs, you know, just to know at the very end, is the brewery cheating or not? Well, when they say there is enough evidence that they're doing so, that's it. There are consequences, and that's one. So I hope that you guys can relate hypothesis testing to real life situations here. This is one of the problems. Okay, let's do question 4. According to official census figures, 80% of couples living together are not married. A researcher took a random sample of 400 couples and found that 39 of them are not married. Test at the 5% significance level if the current percentage of unmarried couples is different from 8%. You guys, you shouldn't even get confused here. It's a percentage question. It's a proportion. What would be the null and the alternative here? Yes?
Equal and not equal to?
Yeah. 0.08. And where is the claim, guys? He says, test at the 5% significance level. If it's the question, what the question is, if the current percentage is different from 8%. So would you guys agree that it is in the alternative hypothesis is in HA? Okay, N is 400, X is 39, and alpha is 0.05. You see, guys, here there is no X bar and there is no S, so you cannot use a t-test or z-test. It must be a proportion test. Okay, let's do it. Stat. Uh, 0.08. Sometimes the students mistakenly make it 0.8. It's 0.08, 8%. X is 39. N is 400. And not equal. Look, I selected that one. I press enter. And now if you want to do a draw, let's do a draw. Z is 1.29. Step number 2. P value is step number 3. 0.197. Which is, guys, bigger than alpha. So your decision is going to be fail to reject HO. And your conclusion is going to be, because you start with fail to, it's going to be there is not enough evidence at the 0.05 level of significance to what, guys? The claim is in HA. Support. The claim. All right. For the remaining exercises, guys, I'm just going to tell you, we got a few more, what tests to use, and I'm going to have you try to finish them so I can still have time to do some other things before we wrap this up. Let's do question 5. Look at question 5, guys. A sample of 1,600 items produced on a new machine showed that 97 of them are defective. So you guys agree this is N and this is X. The factory will get rid of the machine if the data indicates that the proportion of defective items is significantly more than 5%. At the significance level of 5%, does the factory get rid of the machine or not? That's a very good question, guys. You're deciding if the machine is broken or not. You need to make a decision. Can you tell me what the null and the alternative hypothesis will be? They're saying they will get rid of the machine if the percent of defective items is more than 5%. What would be the null and the alternative here, guys?
Less than or equal to 5%. Or P is less than or equal to 5%.
Exactly, and greater than or equal to 5%. Greater than 5%, that's the claim. And what test do we use, guys, here? One proportion, z-test. So we've done quite a bit on a proportion, guys. All right. Let's quickly do this. Stat tests. I haven't done any z-test yet, so I want to find one with z-test. All right. So 0.05. X is 97. N is 1,600. And we want to check that P is greater than See guys how I select the greater than there? And then hit calculate if you like, or draw. Okay, so Z is 1.95. Step number 2. P-value is step number 3. 0.0256, guys, which is small. Do you guys agree with me that this is less than 5%? So the decision is what? To reject what? HO. And what would be the conclusion? There is enough evidence at the 0.05 level of significance to support the claim that the proportion, I'm just going to copy this, guys. Proportion of defective items is more than 5%. So we're saying, yes, we support the claim that the proportion of defective items is more than 5%. My question to you guys, you haven't answered the question in the problem. Would the factory get rid of the machine or not?
They would get rid of it.
Yes, because we have evidence that the proportion of defective item is more than 5%, they should get rid of it. All right. Oh, this is going to be a z-test, and I'll show you why. So please pay attention, guys. We've been doing all t-test and proportion test because these are the newer sections. But let me take you back to the first section, 7.2, and show you why this is going to turn out to be a z-test. And please pay attention because you need to know the difference between z and t. An expensive restaurant claims that the average wait time for dinner is approximately 60 minutes. So they say to wait, just for a seat, it's about 60 minutes. But we suspect that this claim is inflated. What does inflated mean, guys?
Less than.
It should be less than. To make the restaurant appear more exclusive, because when you hear about a restaurant, guys, that takes an hour or two to get a seat, you would think that this is a great restaurant that you should try out. So they try to probably inflate this to make the restaurant appear more exclusive and successful. A random sample of 32 customers, so that's N, yielded a sample average waiting time of 50 minutes, X bar. Oh, now watch, guys. He didn't say anything about the sample standard deviation, but look what he says. The population standard deviation for waiting times to be seated at a restaurant is known to be 10 minutes. Do you guys agree with me that this is not S, this is sigma? Is this clear, guys, where he says the population standard deviation? Look. This is sigma. And because this is sigma, guys, you cannot use the t-test. It must be the z-test. I hope that this makes sense, guys, because that's very, very important, the difference between the two. Is there an evidence to say that the restaurant's claim is too high? So, as you said, because the restaurant claim, we think it's too high, so probably it should be less than 60 minutes. So we need to test the claim that the mean is less than 60 minutes. All right, guys, let's do this. So I hope that I could convince you that this is a z-test, not a t-test, because sigma is given here, and let's do it. So first time today in the review, we get a z-test here. It's not that this is not important, guys, but we did it last time. I spent a lot of time on the z-test. 60. Sigma is 10. X bar is 50. I remember. Yeah, it was 50. N is 32. And we're testing the claim that the mean is less than 60. So the alternative is less than 60, guys. Look, you selected and press enter. Don't forget to press enter. And then draw. Okay. Z is negative 5.66. And p-value is almost 0. So what's the decision, guys? Look, the p-value is 0.
You're gonna reject HO.
Definitely.
But what
P-value
is
low.
alpha in this?
We're going to reject. Oh, this is the claim. Sorry. We're going to reject HO and support the claim. There is enough evidence at the 0.05 level of significance to support the claim that the restaurant's claim is too high. I hope you guys, after this chapter, that you can get suspicious about everything and decide. There's always, just a chance that people inflate the information that they show us. And if we do a hypothesis test, we might prove otherwise.
Mr. Bazzi, where did you get the number for the level of significance?
Oh, he gave it to, didn't he give it to us somewhere? Oh, he didn't. We use 5% usually. So if he doesn't give you, if you go online, guys, and Google level of significance, you're going to see the common one is 5%. I usually do it, but because I didn't put it here, I use 5%. But it doesn't matter in this one. Whether I use 1%, 5%, 10%, the p-value is always small. It's about 0.
Yeah, okay, thank you.
The original data, individual waiting time, is not normally distributed. What theorem allows us to do the calculation? We had a random sample of 32, but the wait time, guys, he said, is not bell-shaped usually. So why were we able to do this problem? Do you still remember the name of the theorem, guys, that would allow us to do this? We did it in chapter 5. If your sample size is more than 30, it's always good to use normal distribution, whether the original population is bell-shaped or not. It's called the central limit theorem. That was in section 5.4.
That only worked because n was greater than 30?
Exactly. If n is not greater than 30 and he doesn't say that the original population is bell-shaped, you wouldn't be able to proceed with this problem. You might come across a problem in the homework where he doesn't give you an original population that's bell-shaped, and he gives you a small sample size, less than 30, and he'll ask you if you can perform the test. You have to say no. All right, let's see how much time we have. All right. I just want to make sure that I finish this. So I might not do the Socrative question today, guys. I'll do it just next time because I want to finish this one. That's the last page. And let me just make sure that I get it done. In a survey of 1273 adults, 668 said it's not morally wrong to change the genetic makeup of human cells. So 668 said it's not morally wrong to change the genetic makeup of human cells. Can you support the claim that majority of adults do not think it's morally wrong to change the genetic makeup of human cells? Once you see the word, guys, majority, it's a percent. What does majority means? More than what?
50%.
That's it. That's right away, guys. And if I say minority, less than 50%. People who are there, please hang in there because I'm not doing the Socrative, so I need to take attendance by just looking at the names. P, more than 50%. And less than 50%. Okay, that's the claim. Well, guys, you know this is a proportion z-test. If we run the test quickly, that's n, that's x, and that's n. Stat, z-test, proportion z-test. Okay, 0.5, need to change it to a decimal. X is 668, n is 1273, and we need greater than 50%. Look, guys, I selected that, greater than, and hit calculate. Z is 1.77, and the p-value is 0.0387. Let me write it down again, 0.0387. And we're doing it at 10% alpha. So definitely this is less than alpha. We reject HO and we support the claim. There is enough evidence at the 10%. Don't forget the level of significance. You have to tell the reader that there could be a type 1 error here to support the claim and just the claim that majority and ... You just copy it right here, guys. Question 8. It was found that 821 crashes of mid-sized cars equipped with airbags, 46 of the crashes resulted in hospitalization of the drivers. Using a 0.01 level of significance, test the claim that the airbag hospitalization is lower than 7.8%. What would that be, guys?
1 prop Z.
Yep. P is less than, change it to a decimal, guys, 0.078. That's the claim. So X is 46 and N is 821, and it's 1 prop Z. Put quite a bit on the prop Z test here, so let's do it. So 0.078. X, guys, is for 846, I'm sorry. N is 821, and we need to check it's less than. Let me do a draw. All right. Z is negative 2.35, and the p-value is 0.0095. You guys should agree with me, this is a very small p-value. P-value low, HO must go, so we reject HO. And then we conclude there is enough evidence at the 0.0 level of significance to support the claim that airbag hospitalization is less than is lower than, lower means less than, guys, than the 7.8% rate. All right. So this is all gonna be scanned, and this is a summary, guys, on how to use the calculator in this section. This page, it gives you a step-by-step summary. Well, you already watched me, just doing this. This is again, this is how to write a conclusion. The step 5, guys, I summarized everything right here, so you can make use of this. So it's 22 pages, guys, that I'm gonna scan and email to you today. So that ends this. Let me show you the StatCrunch part, guys. Some of you asked me about